Hi, good morning. Um, Good morning, students of the world and my students on the grade 8 class. Today I'm going to make a video on how to determine algebraic equations. So I'm going to do it two ways. One is just starting with diagrams, such as this one. We might as well jump into it. So this is actually a linear pattern, and I'll tell you why. This is a linear pattern because if I keep going here, I think most of you could figure out that this pattern is constantly increasing by 2 squares, okay? So one of the skills you guys will have to do, at least in grade 8, is be able to figure out and draw the next two figures, as in figure 4 and figure 5, okay? But this is also about determining algebraic equations. So the best way, the easiest way to really determine an algebraic equation for this is really to make ourselves a data table, okay? Just like the one I'm going to do here, and I do prefer vertical data tables. This column over here in the data table, let's give that the figure number, and we'll designate a letter lowercase f. On this side of the data table, we will count the number of squares. Okay? And why don't we just give that a capital S? Okay? And between the two, figure number and number of squares, the dependent variable, and I've talked about this in class, dependent variable versus independent variable. The dependent variable is the easiest one to figure out because when we're asking ourselves how many squares we have, well, it's the dependent variable because that depends on which figure number you have. And that's why this is called a dependent variable. And that's really what our equation is going to be about. Okay, so let's try to make a data table for this. In figure number 1, how many squares do we have? We have 3. In figure number 2, we have 1, 2, 3, 4, 5. Figure number 3, I think we have 7. 1, 2, 3, 4, 5, 6, 7, yes. And you can probably figure out figure number 4 will probably have 9. And figure number 5 will probably have 11. Okay? And so this is a linear pattern, linear relation, because as the figure number is constantly, and it has to be constant, it can't change from 1 to 2 or anything else. Okay, so it's constantly increasing by 1. The number of squares is also constantly increasing by 2. Okay, and that's how you determine whether a pattern is linear. If it's a constant increase in one variable and a constant increase or constant change, it doesn't have to be increasing all the time, but as long as it's constant all the way through for both of them, then this is a linear pattern. Okay, now that we know it's a linear pattern, how do we determine the equation for this? Well, the equation is always going to be about the dependent variable, s. In this case, it is the letter s, and it's the number of squares. That number of squares has to multiply. There has to be a constant that multiplies the figure number, and we need an adjuster in the end. Okay? So let's determine what is this number that multiplies the f. Well, it's really right here. Whatever this constant increase is, that is the number that multiplies the figure number. So here's our equation so far, 2f. Now, how do you determine what the adjuster is? The adjuster, otherwise known as also a constant. Well, all we got to do really to figure out what this is substitute. I would start off by substituting this 1 into this temporary equation. Okay, because this will be the figure number. This will be what f is equal to. It could be equal to 1, 2, 3, or 4, but the easiest one to substitute is really 1 because we know we can multiply anything by 1. What is, if we do that, substitute the 1 into this f variable, what is 2 times 1? Well, that's 2. What do you have to do to 2 to make it a 3? Well, we have to add a 1. And so that is our algebraic equation. But For us to prove that this actually is the algebraic equation, we need to verify it to be sure. So now what I'm going to do is I'm going to test out this equation to see if it works for any of these figure numbers. For instance, if I test out f equals 3, if f equals 3 here, using this equation, I should get s equals 7. Well, let's figure out if it does. All I'm going to do is I'm going to substitute this 3 in for this f. Then I'm going to follow bed mass and see if this is a, bed mass is multiply first and add after. 2 times 3 is 6, plus 1 is 7. And it does work out, you see? So I know for sure that this is the algebraic equation for this, okay? Let's try another example. This time I'm not going to bother with diagrams. I'm just going to go straight to a data table for this one. So let's say I'll give you a data table. This time, instead of using f and s, I'm just going to go x and y, okay? So let's try out this example. I'm just going to still stick with x equals 1, 2, 3, and 4. Okay? So that should be enough for us to determine the algebraic equation for this. So let's give this some y values. Let's say the y is 0, 3, 6, and 9. So now you got to ask yourself, is this a linear pattern? Well, it is, because this is constantly increasing by 1 and this is constantly increasing by 3. And again, mind you, and later on, this doesn't necessarily have to be increasing. These could be also decreasing or vice versa, okay? But let's keep it simple in this example. Constant increase in one, constant increase in the other. By the way, if you ever want to describe this, and it is one of the things that I ask my students to do. If you were to describe this, we try to keep it simple, okay? And just tell us what is happening to the x, what is happening to the y. So here's a description. As x increases by 1, oops, what is happening to the y? Y increases by 3. Okay? And so whenever you get a question where it says I actually ask you to describe, this is all I want you to do. And now for the equation. Well, what is our equation going to be about? Again, our dependent variable is the y, so it is going to be y equals something times the x. Oops, a little bigger here. Something multiplied by the x, and then we'll figure out the adjuster after. Okay? So what is the number that goes in front of this x? He's right here. It's the 3. It's this constant increase. Now, as long as this x is increasing by 1, you can do that. But otherwise, in later grades, you'll see that it is this change divided by this change. In this case, our case is 3 divided by 1, which is 3. Okay? And now we're going to figure out what our adjuster or our constant is by just using this x equals 1. Okay? Now, if you do this by mental math, if I substitute this x equals 1 into this temporary equation, it should be 3 times 1, okay, which is 3. What do I have to do to 3 to make it 0? Well, I have to subtract 3. So our equation actually here is 3x minus 3. Okay? I'm going to try another example just so you can get a hold of this, get a hang of this, okay? So here's our equation. It's 3x minus 3. Does this make sense? If I substitute a 1 here for this x, that'll be 3 times 1, which is equal to 3. What do I have to do to 3 to make it a 0? I have to subtract 3. Okay? So now let's see if we can verify this. Do this in this corner over here. Let's see if we can verify this to see if this actually is our equation. Y equals 3x minus 3. So now I'm going to try to see what if x equals 3. Now I'm going to substitute this 3 for that x to see if this equation actually works. And if it does work, then I should end up with y equals 6. Do I? 3 times 3 here is 9. 9 minus 3 is 6. So it does work, you see? So this definitely is our equation for this. Y equals 3x minus 3, sorry. Y equals 3x minus 3 for that one. Okay. Let's see if we can do just one last example. Okay. This time, maybe I can give an example where the y is actually decreasing. Starting at 1, 2, 3, 4 for the x. Also increasing by 1 at least. Let's keep this nice and simple. But what if I started you off here with, let's say, 9. And then it goes to 5. And then 1. And then this will be negative 3. Please take note, this is all increasing by 1, but what is happening to the y? Can you see that it is decreasing by 4? So we're going to have to put a minus 4 here. Okay? So in this example, unlike the ones before it, this is no longer increasing, this is decreasing. So if I wanted to describe this, I would have to say, as x increases by 1, y doesn't increase anymore, it decreases by 4. So there's a description. And now let's try to figure out an algebraic equation for this. Y equals something multiplied the x, and then we'll figure out the adjuster or the constant after. I like to call it adjuster because it does adjust our calculation in the middle. Well, what is the number that goes in front of here? Well, it's right here. Whatever this constant change is, that is the number that goes in front of this x or multiplies with this x. So in this case, it'll be negative 4x. And now we just have to figure out our constant or adjuster. Well, this time, yes, I can still use this one, okay? So if I multiply, if I use this x equals 1 and substitute it in this temporary equation, what is negative 4 times 1? Well, that's negative 4. What do I have to do to negative 4 to get a positive 9? Well, I think I have to add a plus 13 this time. Let's try this out. What do I mean? If I substitute this 1 into this x, I get 4 times 1, and this will be negative 4, and negative 4 plus 13 equals 9. Okay, so here's our adjuster, or our constant, it's plus 13. Yes, I know it's a little bit more challenging, but as long as you know those steps, you can pause, rewind this, and listen to it. It's always this constant change multiplying that x, or that independent variable. So if this is our equation, negative 4x plus 13, it should work with any of these x values. I'm going to try it with x equals 3. If I try to substitute this 3 into this x, my answer should give me positive 1. Let's see if it works. Negative 4 times 3 plus 13. Negative 4 times 3 is negative 12. And negative 12 plus 13 is equal to 1. So it does work. This is our equation for this. This is our algebraic equation for this linear pattern. So, students, I hope this helps. Please use this video to help you out with your assignments. And if you have any questions or a disclaimer, go ahead and post it in the comments below. And thank you very much for your attention, and good luck. Bye-bye for now.